Hello. Today I'm going to show you a few things to do with regression, simple linear regression, step by step, very carefully on our TI-83 or 84 calculator. I'm starting with a hypothetical data set where you have X values that are 10, 20, 30, 40, 50, and Y values correspondingly are 16, 23, 38, 50, and 72. So the first thing I want to do is to put this data in our calculator. So if you have this kind of calculator, to get into what I call the L columns where you store data, you do your stat button followed by enter. And there you see I have gone ahead and keyed those in. L1 is my X values, L2 is my Y values. Now, when you're doing regression, many times you need to find out what the linear correlation coefficient is. We call that R. And so there's a key sequence you need to do to turn that on your calculator, which I've written right here. To include that value of R, we have to press second function key, the second function up here, followed by 0. That takes us into the catalog menu. We want to scroll down as far as we need to, pretty good ways, to get alphabetical listing down to D, to the diagnostic on. And that is going to take a little bit of time. There we go, diagnostic on. Press enter twice. First time chooses it, second time executes it. It says done. Great. Now to run the actual regression, we want to press our stat button. We want to come over to calc with the right arrow and come down to number 4. Notice how it says linreg ax plus b. That's your simple linear regression. Choose that with your enter key. And on this model calculator, because I have L1 and L2 for my X and Y values, that's the default. I don't need to specify anything different, so I just press enter. And there's my result. So you see here, the result gives you the slope 1.39, the y-intercept negative 1.9, the value of R 0.985 rounded off. The regression equation would be this y hat equals 1.39x minus 1.9. So the interesting thing I'm going to show you right now is how to compute what we call the sum of squared residuals. So go back to this screen where you have your L columns, which is your stat and enter. And we're going to go over here to L3 column. We're going to put these y hat. Y hat is what you call the predicted or fitted or modeled value of y from the equation. So we want to cut and paste this equation we found into a certain position. So here's how we do that. Press the y equals button by itself, and that's where you want the equation to go. Now we'll start with it blanked out there. That's how you start, okay? Then you do this key sequence I've written right here. You press the vars button. Vars is right here below your arrows. We then go down to number 5, statistics. Choose that with your enter key. We're now sitting on an XY menu. We want to go over to the right to EQ. Once you highlight EQ, notice that number 1 is regression equation, so choose that with your enter key. We have now cut and pasted that equation so that if I wanted to do a graphic, I could actually graph on here with the regression line with my data points. But right now what we want to do is go back to the L columns. So go back to stat enter. And I'm going to enter a formula here for L3. When you do formulas on your calculator for your L columns, you want to go up with your cursor and highlight the heading of L3, then press enter. That puts you down in the tray where the formula is going to go. Now we're ready for that same key sequence. So, oops, I've got a minus sign gotten there somehow. Let me clear that out. Okay. The same key sequence except for this y equals. So it's going to be vars. Then we go to number 5, then enter, over to EQ, and then enter. Now there's one glitch with this. Because we're in the L column mode, this expression right here has an X, and this X is not understood when you're in L column mode. We have to change it to what it really is. We know that our X's are in our L1 column. So put the cursor on top of the X. Once you have it there, we're going to key in the L1 combination, which is second function 1. So I'll do second function and then 1, and you see how it puts an L1 there where the X was. Now press enter. Voila, we have in L3, those are our fitted values of y hat. And so let me copy those down. We have here 12, followed by 25.9, 39.8, 53.7, and 67.6. Now, what we want to do is get the residuals. Residuals are defined to be the actual y value minus the predicted value of y, which we call y hat. So the formula I'm going to put in my L4 column is going to be just that. Well, if y is in L2 and y hat is in L3, then L4 formula needs to be L2 minus L3. So we need to put that formula in. We need to go over to the right to the L4 column, highlight your heading, press enter to get down the tray, and now I want to key in the command L2 minus L3, which will be second function 2 minus second function 3, like that. And you press enter, voila, there you have in the next column, L4, your residuals, which happen to be 4, negative 2.9, negative 1.8, negative 3.7, and a positive 4.4. So now we want to get the sum of the squared residuals. And good news, it's not going to be much longer here. All we have to do is do a one variable stats command on the L4 column. So recall what that is. That is when you press stat, come over to calc. So let's do that. We press our stat button, come over to calc, choose your one variable stats, and make sure you tell it L4, which is second function 4, puts the L4 in there, then enter. And what we want to read off here, sum of squared residuals, so the sum of the x squareds, whatever we see there, and if you look on the screen here, sum of the x squareds, right there, is 60.7. You see the 60.7 right there. That is what we're looking for. That would be our answer. And so the sum of the squared residuals is the lowest possible when you use a regression line. If you had any other line running through the midst of these points, you would have a higher sum of squared residuals than the regression line. That's why we call it least squares regression. Thanks for being here for this video. We'll see you next time.